Hello everyone. So in today's session, we are going to be discussing on the topic of type conversion. So we can also call this as typecasting. So what exactly is this type conversion? So this is converting a variable from one data type into another data type. So this is what we call as type conversion or typecasting. That is, say for example, I am creating a variable which is of integer data type. Okay, we know that integer can accept only whole numbers. Okay, now I want to convert that integer variable into a floating point value. Or I have created a float. Float, it can accept fractional values also, that is values with decimal points. So I have created such a variable, but I want to convert that variable into an integer value. So like this, to convert between the data types. Okay, we follow some procedures for it. So this conversion is what we call as a type conversion, or another alternate name for it is we can also call it as typecasting. Right. So basically, the typecasting is of two types. Okay, there are two ways to actually do this. One is what we call as an implicit typecasting, and the second option is your explicit typecasting. Now, implicit typecasting, which is also known as automatic type conversion. So now you can get an idea with the word automatic. So automatic type conversion, we are not going to do anything. It is going to happen on its own. That is why we call this type of type conversion as automatic type conversion. So another alternate name for it, we also call it as widening conversion. So one of the type conversions what we have is implicit. This implicit type conversion can also be referred to as automatic or widening conversion. So what is going to happen here? This sort of type conversion is going to be performed by my compiler. So as a programmer, you don't have to do anything. Your work in implicit type conversion is zero. So we are not going to do anything. The entire process is going to be taken care by my compiler itself. That is why we call this as automatic type conversion. Now, whenever this automatic type conversion happen is whenever we want to go from a low-end data type to a high-end data type. From a low-end data type to a high-end data type when we want to go. At this situation, the compiler will automatically do this process. So we don't have to do anything. So upgrade of the data types to the largest value. Okay, say for example, I have a char data type. I want that char to be converted into a shortened. It is automatic because char occupies only 1 byte of data. Shortened occupies 2 bytes of data. From a smaller data, I am going to convert into a higher value. That is why we call it as widening. Okay, so this type of process is actually taken care automatically by my compiler. Same way, from a short to an int. Again, we know int occupies 4 bytes. So you have the maximum and the minimum value allocated for the int type. So from int to an unsigned int. So that to long. So all these types. So from a low-end data type, converting into a high-end data type, the process is going to happen automatically. That is why we call it as automatic type conversion, or rather implicit type conversion. Okay, so responsibility of the compiler. Now, let us see the small program to actually understand what is happening here. Okay, I have created a variable, say, of char data type. We know what is a char. Char data type is used to store a single character. So, what I'm saying, char A. Here, A is the name of my variable. And what is the value I'm going to store inside this variable? I am storing the value small a, single character. Right, now, I am declaring an integer variable. So the integer variable, I am calling it as b. And what is the value of b? I am giving the value as 20. Now, I am going to perform an addition operation between the values a and b. Now, A is belonging to one data type, B is belonging to one data type. So now I want to perform an addition between these two. So what is internally going to happen? How is my compiler going to handle this situation? So first point you have to note down is char and int, which is the bigger of the type integer. So the result of an operation between these two is always going to be an integer, because that is the biggest or the highest data type you have here. So what is my compiler going to do is, when it takes the char value, this A, okay, now we know that ASCII value plays a crucial role. We have something called as ASCII value, that is each and every character present in our keyboard has an ASCII number associated to it. Always remember, from the time of computers invention till today, they understand only zeros and ones. Whatever instructions you are giving, it is not going to understand, right? It understands only zeros and ones. So I am giving the variable as A. If it is a number, it is easier for me to convert to a binary. I can keep on dividing it by 2 and I will get the binary value. But how to get a binary equivalent of A? So that is why we have the process of ASCII. So what is going to happen here? Every character has an ASCII number associated with it. So ASCII value of small a. ASCII value of small a is 97. So here my compiler is going to do an implicit conversion. So even though you are creating this a variable as a char and you are assigning a single character as its value, internally, what is my compiler going to do? It is going to take the ASCII value of this character, which is nothing but 97. So when it is going to perform the addition, what it is going to do? This is 97. B value is 20. So 97 plus 20. It is going to return the output as 117. So please remember what is happening. Implicit conversion takes place. Here, as a programmer, are you doing anything? No. We have just simply written the code. We are executing the code. That's it. Whatever the conversion that is happening, it is purely taken care by my compiler only. So the output of this program, it is going to be coming as 117. Okay. Now, let us see one more example to understand this little better. Right. Now, look here. I have taken a float. Okay, float value x. So we know float, as I said, it can accept decimal value or fractional values. So I am going to give the value as 20.12. This is the value given to this x. Now, what is that I'm saying here? Int y, in data type, whole numbers. In data type can accept only whole numbers. So I am saying int y is equal to x. Now, what is the value of x? 20.12. Now, this floating point value, I am assigning to an integer variable. So, please remember, float data type, I am assigning the value to an int. So, now what is going to happen? So, whenever you are doing such an assignment, the compiler will automatically do a conversion. It is going to truncate the decimal value, because integer is whole numbers. Whole numbers means only this 20. 20 is the whole number and 0.12 is the decimal fraction value here. So when my compiler is going to convert it into an integer, it is going to truncate this 0.12 value. It is going to store only the whole number, which is 20, inside the y. So again, an implicit conversion, or what we call as an automatic conversion, is taken place. So as a programmer, again, we are not doing anything here. The compiler is taking care of all these things on its own. So this is what we call as implicit type conversion. Okay, so let us execute this program also. We'll try to execute both of our programs once and check it out how it is going to be working. Now, this is our first example where we were adding a char and an integer together. So there you go. I'm just copy pasting the code here. So see, as I said, one char data type and one integers. I'm going to add both of these values and let us see what is the result that is going to get printed for us. So as I said, whenever you're practicing the program, try to work it out in both online and offline compilers. because there are some predefined functions, some situations which may not work properly in online compilers, not in Instax. I'm telling you, any online compilers, there are certain functions which is not supported. So whenever you're practicing any programs, as I said previously also, try to work it out in both online and offline compilers. But here in our case, we are not using any predefined functions, so it is absolutely fine for us. So see what happens here. It is giving me the value as 117, that is A plus 20. So what is happening to this A? The A is internally converted into its ASCII number, which is nothing but 97. So 97 plus 20. That is how it is able to produce this value for me. Same way, the second program what we saw, the second example what we saw for the implicit type conversion. So let us run that program also. So see here what I'm doing. Same way, created a floating point value and I'm assigning that variable's value to an integer. And look at the result what I'm getting. So the floating point value, that is x value, is 20.12. But when I am assigning that value to y, see what is happening. It is taking only the whole number. Again, my compiler plays a crucial role in all these type of programs. Now, coming to the second part. Okay, all these are implicit or automatic conversion that is happening. But what we have to concentrate on as a programmer, we have to concentrate on explicit type conversion. So explicit type conversion is what we call as user-defined conversion, typecasting, or we also call it as narrowing conversion. Narrowing, we are going to narrow the, that is from a bigger data type, we can also fit it into a smaller data type. That is why we call this as narrowing. Right now, explicit type conversion is 100% programmer's responsibility. So you, the programmer, has to do this. So he or she is the one who is responsible of doing the process of conversion. So explicit type conversion is how the programmer converts from one data type into another type. So for doing this, we have to follow certain syntax, certain rules. So how to do it is, first within the parenthesis, we are going to mention the data type. That is to which data type we plan to convert. That data type you are going to mention within the parenthesis. Then after closing the parenthesis, you are going to mention the value, or rather to say the expression. So it can be a variable name, it can be some sort of calculation. So whatever it is, okay, you have to mention that outside after the closing of the parenthesis. So what will happen is, whatever the variable or the expression you are giving here, okay, that will be converted into the specified data type. So whatever data type you're going to specify inside this parenthesis, this expression will be converted into that particular data type. So this is how our explicit type conversion is going to be taking place. And as I said, programmer has to take care of this process. Right, so let us try to understand this with an example. Now, have a look at this program. So what are we doing here? We have created two integer variables. So I have created a variable where I'm saying A is equal to 35 and B is equal to 20. Now, I am going to perform a division operation on these two integer variables. Now, one very important point, I hope you guys remember from our arithmetic operators. So whenever we are going to perform any data type, any operations, the result of the operation will be same as that of my data type. If I am going to apply the division operator on two integer values, then the result also will be an integer. So the result of the operation also is going to be an integer value only. Okay, first let us confirm that. Right, so what I'm going to do. Right, so first let us just execute this program. I'm not doing any type conversion initially. I am just going to say, right, so A divided by B is equal to whatever is the result is going to get printed in this particular place. Right. So no need of any type conversions. First, I'm directly just going to execute the program. So let us see what is the output we are going to be getting for this. Right. See here what I get. 1, which is nothing but a whole number. Why am I getting like this? Why am I getting like this? I am getting like this because both my numbers are integer numbers. So whenever I perform an operation on an integer number, the result of that operation also will be an integer value. Okay, so now what I'm going to do, I'm just going to change here to percentage %f. Now, you know what is percentage %f? Percentage %f is the format specifier that we are going to be making use of for the floating point. So what I'm saying, A divided by B. This is the expression. This is the expression or the operation I'm trying to perform. So I am saying whatever is the result of this. Okay, whatever is the result of this, store it here as a floating point. Print the value here as a floating point. Right, now let me run this. See, what is the output you're going to be getting? 0.000 like this you're getting. Is this a correct output? No. Why am I not getting an output here? Because the result of the operation is an integer value and you are using a percentage %f, which is a floating point format specifier to print that result. How will it match? My result is going to be integer, but I am using a format specifier which belongs to the float data type to print a value. So how is it possible? That is why you are getting the result as 0 point somethings. Now, if I want to do this, that is, if I want to convert the integer into a float, I have to perform the typecasting. That is, I want to convert the data from one data type into another data type. Please understand, among integer and float, both occupy only 4 bytes of memory, but float has a higher precedence. Float has a higher precedence. Float is considered to be a higher end data type. So converting from a high end data type to a low end data type is not possible automatically. Low to high we can do it, not a problem, but high to low is not possible automatically. So that is why we are going to perform the typecasting here. Okay, that is why we are going to perform a typecasting here. What I'm going to do here, I am just going to say, what is the syntax? Within the parenthesis, mention the data type. Whatever data type you want the value to be converted, mention that data type here. So what I'm going to do, float. Now run the same program. See what is the output you are getting. Now there is no zeros. You're getting a proper exact output, 1.75. So this is what you're going to do in explicit type conversion. Converting one data type into another. Here, converting an integer into a float and then printing the result of that operation. So we have to follow the syntax of how we are going to be doing it. That is what I have done here. So here is a part of my type conversion which is going to be happening and the output of what I will be getting for it. Right. Okay. Let us try to understand one more example before wrapping up the session. Right. So here, see what I'm going. I have a float. Okay. I have created a floating point. Now, when I am printing the value of A, obviously, since it is of a float data type, what is the format specifier you have to use? Percentage %f, because that is only going to print my float point values, floating point values. Now, here, see what I have done. I am saying percentage %2f. Now, again, remember, what is that %2f? I want to print only 2 digits after the decimal point. So, float is going to accept fractional values. After the decimal point, I want only 2 digits to be printed. So that is why I'm saying here percentage %2f. Right, now I'm saying A. So whatever is the value of A, that is going to get substituted in this place. Done, no problem. Now look at the next to print statement. In the next print statement, I am using percentage D to print the same A value. Now, will this work? No, definitely not. Why? Because percentage D belongs to my integer data type and A is a floating point variable. So how can I use percentage D to print that value? It is not possible to do it directly. So again, I am going to take the help of my type conversion. So what I'm doing, I am converting this floating point data type into an integer and then I am printing the value. Now, please understand one very important point here. What is going to happen? Integer percentage D can accept only whole numbers. So when I do this process, the decimal value is going to get truncated. So the output is going to be coming only as 45 for the second print statement. Okay, again, an example of explicit type conversion or what we call as a typecasting. So let us execute this program also. So let me just copy this code. Right, there you go. Okay, see here first, let me try it without typecasting. Okay, without any type conversion, I'm directly printing the values. So see what is the value you're going to be getting over there. Since I have used percentage D, what is the value we are going to be getting for that? See what it comes. Some value which is garbage value, which has absolutely no meaning here. So that is why I said typecasting is necessary because A is a floating point value. I am going to typecast it now. So convert it into an int and then execute the same piece of code. See this time what you're getting as the result. 45. So the decimal point here is getting truncated and only the whole number. Okay, only the whole number is getting printed in the place of the percentage D. So this is how our typecasting is going to be working. Something which is very, very useful. Explicit type conversion is very frequently used in our programs in the upcoming topics as we go, especially with pointers. So one very, very important topic in C language is our pointers. So in the concept of our pointers, in the concept of dynamic memory allocations. So in all those places, explicit type conversion plays a very crucial role. Right. Okay, guys. Thank you. See you in the next video.